Good morning, class. I'm Mr. George Owich, a teacher of chemistry. This morning, I'm going to take you through energy changes in chemical and physical processes. Now, just to start with, energy is defined as the capacity to do work or the ability to do work. The branch of chemistry which deals with the energy changes is known as thermochemistry. We have various forms of energy, and these forms of energy are interconvertible. That is, they can be converted from one form to another. And the forms of energy, for example, that we have include the chemical energy, kinetic energy, potential energy, and the electrical energy. The SI unit of energy is usually measured in joules, and therefore, when 1 mole of a substance is involved the energy is given as kilojoules per mole, which can be written as shown. Now, under energy changes, we are going to discuss on exothermic and endothermic processes. An exothermic process involves heat energy being liberated to the surrounding and is normally characterized by an increase in temperature of the surrounding. That is, when the reaction takes place, the heat energy is released, and when measured using, for example, a thermometer, you realize that the temperature of the surrounding normally rises because the bond breaking or bond formation involves heat energy being released. Endothermic process involves heat energy being absorbed from the surrounding. When heat energy is absorbed from the surrounding, the process is characterized by a decrease in temperature of the surrounding because the heat content of the surrounding is absorbed in the bond formation or bond breaking process. Let's look at the energy level diagram. What do we mean by energy level diagram? It's a graph of energy level against the reaction path or the reaction course, which can be presented as the energy in kilojoules per mole on the y-axis, and we have the reaction path of the reaction course on the x-axis. Let me refer you back to the endothermic and exothermic. These are involving energy changes. And on the energy level diagram, we normally have the reactant and the product. When the reaction is exothermic, the reactant normally appears above the product, and therefore the overall enthalpy change is presented as a negative, because in the reaction process, heat is released to the surrounding or liberated to the surrounding, where the enthalpy change is given by subtracting the enthalpy of the heat of the reactant from the heat of the product. Under energy change, we normally have what we call the thermochemical equation. The chemical equation is a balanced chemical equation that includes the enthalpy change. To write a perfect thermochemical equation, the students need to write the chemical equation, balance it, give the state symbol, and then include the enthalpy change for their processes. Students, when you see a negative sign on an energy change, it shows that the heat change was exothermic, meaning the heat is released to the surrounding during the chemical process. Let us try something on the molar enthalpy changes. The word molar just as touch under the moles. Molar enthalpy changes is the heat change involved in a process where 1 mole of a reactant is used or 1 mole of a product is formed. In that case, in chemistry, we normally deal with the enthalpy change per mole. The enthalpy change per mole can either be in unit for enthalpy joules or kilojoules per mole. When, for example, you are asked to calculate the heat change of solution of a substance, heat change of solution of a substance, just when you take a solute, put the solvent, you form a solution. When you want to calculate the heat change for that solution, it simply means you calculate to give us the molar heat of solution. That is the heat change when 1 mole of that substance dissolved in a solvent to give us a solution. Let us look at what is involved in heat change in a physical process. The physical processes, just as you touched earlier in your Form 1, a physical process is always reversible, and there are changes that occurs when a substance is heated. For example, when you heat ice, what happens when ice is heated? From the time it changes from the solid until we obtain the gaseous state. There are physical processes that takes place. In the heating process, when you start heating, the temperature normally rises constantly until the substance reaches the melting point. The process taking place there is melting. Then, further heating results into vaporization. The reverse process is possible since this is a physical process. Now, we have heat change that occurs when a substance changes to liquid at that melting point, the latent heat of fusion. But we need to recall the definition when 1 mole of that substance is heated to change from the solid to the liquid state. That is molar heat of fusion. What is molar heat of fusion? It's the amount of heat required to convert 1 mole of a solid to a liquid at its melting point. In the same case, when 1 mole of a substance is heated, for example the ice, from the liquid state until it is converted to the gaseous state at boiling point, we refer to that as molar heat of vaporization. Students, let us look at the heat changes in chemical process. The heat changes in chemical process involves bond breaking and new bond formation. That is bond formation. Bond breaking is an endothermic process. That is, heat is absorbed. Bond formation is normally an exothermic process. And before 2 molecules react, they are first converted into constituent atoms. This process, where the molecules are converted into constituent atoms, is referred to as atomization. Students, let's look at an example. When hydrogen reacts with chlorine to form hydrogen chloride gas. We have 1 mole of hydrogen react with 2 moles of chlorine gas to give us 2 moles of hydrogen chloride gas. In this case, the energy change or the heat change normally takes place. And therefore, the bond breaking for the reactants must take place. That is atomization. The breaking of the constituent atoms. Then, new bonds are formed. In this case, to get the heat energy change or heat change, we have bond breaking energy minus the bond formation energy. To present this one in a simple atomization process, we have hydrogen molecule, the bonds holding the hydrogen atoms being broken, chlorine molecules being broken. Then, in the bond formation, we have hydrogen chloride gas. And there are 2 moles, therefore it is 2 moles of hydrogen chloride being formed in the process. Mathematically, when you present this, we normally have what we call bond energy. The bond energy refers to to the energy associated to a particular bond. For example, for breaking the bond holding the hydrogen molecule, that's hydrogen and another hydrogen, we have 436 kilojoules per mole, and that continues as shown on the board. Chlorine, chlorine, hydrogen, chlorine. When you refer to that, you can be able to get the energy change for that process. That is, for hydrogen, hydrogen 436 plus chlorine to chlorine 432. When you add that, you get the total energy for bond breaking energy. Then for bond formed, it is 2 into 431, a total for bond formation energy. Therefore, in summary, to get the total heat change or energy change for the process of formation of hydrogen chloride, we'll have bond breaking minus bond formation energies. Students, thank you for listening for this lesson, and I welcome you next time when we'll be looking at the next step in the thermochemistry process. Thank you and welcome again next time.